This video was sponsored by PCBWay, an online service that will quickly develop your PCB and CAD prototypes. More on them in the course of this video. Hi, you're watching Floyd Steinberg's YouTube channel. Today, the LMN-3, the most ambitious open source synthesizer I've ever built on this channel. And this is going to be a long video. I show you how to get the PCBs, the 3D prints, all the other components. I'll show you how to build it and how to compile and configure all the software needed. And there will also be a sound demo in the end of this video. So without further ado, let's start. So the LMN-3 made quite a splash in the media when it was announced some months ago, and it was heralded by many as an OP1 killer. That's maybe because the OP1 had quite a high release price, as you perhaps heard. So in order to build this synth, you need a lot of parts, but mainly you need the PCB and the 3D printed parts, and that's the first thing we're going to obtain today. So before I started this video, two things happened. One of my viewers sent me his spare part PCB kindly and asked me to do this video. And the other thing that happened is PCBWay contacted me and asked me if I could promote their service. So one and one came together here. And so let's see how we can develop the PCB and the 3D prints at PCBWay. And the first thing you need to do is you need to go to the project's webpage and download the Gerber files. You'll find the link on the homepage of the project, and then just download the zip as seen on screen right now. And the second thing you need to do is to download the MCAD or MCAD files from the same webpage, also linked on their homepage. And once you got those two files, go to PCBWay.com and then create an account, and then you can upload those files. And let's take a look at the options you got here. Once you're on the PCBWay homepage, enter the dimensions of your project into the instant quote form. For the LMN-3, that's 305 by 95 by 1.6 millimeters. There are 2 layers and the minimum quantity is 5. Now press the Quote Now button to go to the next screen. Here you can leave most of the options as they are, but you can change the color if you like to. I chose white here. And then press the Calculate button and save this to your card. Now log in if you aren't and press the Add Gerber File button. You can now upload the zip file or the Gerber files themselves, then press the Submit Order button. Next, navigate to the CNC and 3D Printing tab. Now select the STL files and drag them to the Select STL Files area. Once again, leave all the options as they are and then press Submit Request. And now an actual human being will review your request, and once that is green-lighted, which takes about 3 or 4 minutes, you can then place your order. So 6 days later, a parcel was delivered to my door, and yeah, let's open this up and see what's inside. Okay, there's some merchandise, everything is wrapped up very well, and yeah, here are the PCBs and the 3D prints. So let's unwrap that and take a look at this. And yeah, I think the 3D prints came out nicely. Let's take a look at the PCBs. They look so nice, with a white finish. Yeah, I'm quite satisfied with how these turned out, and now we've got these in the back, let's take a look at what else we need to finish this project. So here's the list of all the things this project calls for. You will find links to this in this video's description and also on the project's homepage, but I will use some cheaper alternatives here and also link them. Of course, we need the PCB and the 3D prints. This is a Teensy 4.1 microcontroller and a 4-inch touch screen. Instead of the Hyperpixel screen, I used a product named HyperTouch, which is around half the price. Here are some encoders, you'll need 4 of them. You also need around 50 diodes. And here are some keycaps and microswitches, you'll need 45 of each. Some sticky rubber feet so your LMN-3 doesn't scratch the table. A Raspberry Pi. I used my Raspberry Pi 3B here, which works just fine. The Pi 4 is extremely expensive right now. Instead of $50, you'll pay around $150 if you want to buy a new one. Not on screen are some M2.5 nuts and bolts and the micro USB cable. The price of this project is hard to stomach at the moment, so the best thing is you already have some of these parts lying around in your drawer or somewhere. Right, now we can start soldering, and the best place to start with are the diodes. Place the board in front of you so the smaller edge is facing right, and now take a look at the symbol on the PCB. There's a black line on the left side. You need to insert the diode so the black ring found on its body faces the same direction. It's a good idea to bend the diode's legs over your thumb, some millimeters away from its body, before placing it on the board so you don't damage it. Now pull the legs through the tiny holes, press the diode down onto the PCB firmly and solder it. And after that, take some pincers and cut away the excess legs. The result should look something like this. And now repeat that 48 times until all the diodes are placed on the PCB, and the result looks like this. The next step is to solder the Teensy 4.1 to the board. Turn the board around so you can see the diodes, then take a look at the way the holes are aligned on the PCB. The Teensy has the same pattern on its body, so align it accordingly. And then carefully push the pins through the PCB. This might take some tries and readjustments, especially if you used the Teensy in other projects previously. It's a good idea to lay the board and the Teensy on its back once all the legs are through, and gently but firmly push the PCB until the Teensy is in place. Then solder all the legs. Here, having a soldering iron with a small tip is really the key to success. I've linked my iron in this video's description. It's battery powered and has an LED light, which really helps seeing what you're doing. Then again, take your snipping tool and cut away the legs carefully. It's a good idea to hold a plastic bag over the board to prevent the legs from flying all through your room and into your eyes. Once all this is done, your board should look like this, and you can never ever use the Teensy in any other project again. Oh well. Now it's time to solder the microswitches for the keys. Best is to begin by placing some of the switches on the upper part of the case as shown in the video. The pins are facing downwards or south. Now the project's webpage suggests to check every switch with a multimeter, but if you bought your switches new, that's not necessary. Now align the switches on the PCB and start soldering. But depending on the temperature where you are, the 3D printed part could extend and then misalign with the PCB. In that case, placing it in the fridge before soldering could help, or applying a bit of pressure when pushing it in place. And now you can push the keycaps onto the microswitches. The last parts to solder are the 4 encoders and the joystick. I'll just show the joystick here. Carefully align the pins with the board and then push them through the PCB and then start soldering. And finally it's time to assemble the screen and the case, and I'll just let the footage roll in an ASMR kind of way. I must admit I forgot to order 2 parts of the case at PCBWay, so I had to help myself with these toy pearls from IKEA. I think the result looks quite good too. So enjoy this and I'll see you later. And with that, hardware assembly is done. I still will print out the keycap stickers and glue them to the keyboard, but all in all, yeah, that's it. And now one thing is left to do.
Get down, baby, get down. Right on, get down.
I'm afraid we're not done yet, because now we have to compile the Teensy firmware and install the software on the Raspberry Pi. And I'm going to walk through this step by step. Here we go. To compile the Teensy firmware, you need Visual Studio Code. Link is in this video's description. Download it for your operating system of choice and install it. Then within Visual Studio, open the View menu and click on Extensions. On the left side in the search bar, type Platform I/O. Then click the Install button for the Platform I/O IDE button and wait for the plugin to be installed. Now, from the project's homepage, download the LMN-3 firmware zip file as shown in this video and unzip it to your desktop. Connect the Teensy to your desktop PC using the USB cable from your LMN-3. Then in Visual Studio, click on File, then on Open Folder, and then open the firmware folder you unzipped to the desktop previously. In the left column, double-click the platform.io.ini file and then click the checkbox in the blue bar at the bottom of the Visual Studio Code window. The firmware will take some minutes to compile and it will be transferred to the Teensy automatically. Once the log file reads success, you can then unplug the cable from your PC and reconnect it to the Raspberry Pi. We can now continue installing the Raspberry Pi. Now, from the Raspberry Pi homepage, download the Raspberry Pi OS installer for your system of choice and install it. Insert an SD card into your PC and launch the installer. Click on Choose OS and on the System Other, select the 64-bit version of the Raspberry Pi OS. Click on Choose Storage and then select the correct SD card. Then click on Write and wait until the install is through. Now, insert the SD card into the Raspberry Pi, connect the screen, a keyboard and a mouse and run through the setup process. Wait for all the updates to install and once you're on the desktop, open a terminal and enter the git command as seen in this video now. This will download the latest release of the LMN-3 DAW. Unzip this and run it to check if everything works. Now we need to make the screen work. If you bought the model I linked in this video's description, you need to install drivers and turn the display by 180 degrees. Also, change the setup file according to the instructions to make the touchscreen work. Last but not least, download the SVG file containing the icons and print them onto a sheet of foil. Cut out the icons and glue them to the keycaps according to the photo on the project's homepage. This step is crucial for understanding the DAW tutorial. And with that, we finished building this mini workstation. Now, a short but important special broadcast, and then we'll continue with taking a look at the software and creating a short track. And then we'll see if this is really an OP1 killer. Oh, by the way, if you like content like this, and if you want to see more on the LMN-3 and other open source projects and synthesizers in the future, please subscribe to this channel. And if you want to support me financially, you can use the Super Thanks button under this video or buy some of my music on Bandcamp, even if you don't like it. Starting today, you can also join this channel, which is the YouTube equivalent of Patreon. Building all these projects is increasingly time and money consuming, and your support would be greatly appreciated. The first channel members will also get some benefits, for example, the leftover PCBs from this project or some other synths I built in the past. Thank you. Okay, let's begin this demonstration with a real-time boot phase. You just start the synth by plugging in the power cable. Here we go. Wow, 1 minute and 30 seconds. Okay, before we can begin using the sampler and the drum plugin, we need to upload some samples to the LMN-3. Drum samples should reside in one folder per kit, and you can upload them to /config LMN-3 drum kits. Inside the drum kit folder, you then must create a text file describing the contents of that folder and the node each sample is assigned to. All other samples can just be uploaded to the samples folder in the same directory. And with that out of the way, we can now start creating a track. So here it finally is, the finished LMN-3 ready to create a track. Let's quickly walk through the user interface elements. Here's the screen, of course, and there are 4 encoders which will let you change values on the different screens and menus. The labeled keys here are for switching screens and for working on track data. We'll get to that soon. This is a pitch bend stick and the unlabeled keys are for playing notes. On the screen you can now see we're in track mode. If I want to play notes, I need to load an instrument, and I'll start with a virtual analog synth. So press the plugin key and then press plus to add a plugin. Now you can use the 2 encoders on the left side and choose a category and an instrument. Choose the 4OC plugin and then press the second encoder and wait until the plugin is loaded. I want to create a plucked sound for this track, so first we need to change the sine wave to something else. Change this to saw with the left encoder. With the second encoder, add more voices so you get the supersaw sound. Holding the lemon key takes you to a secondary screen on which you can detune the oscillators you just added. Let's also add some stereo spread. Pressing the plus key here will take you to the other oscillators, but we will use only one. On the 5th screen there's an amp envelope and we will change that so we have a plucked sound. Press plus again to go to the filter screen and change the filter type to a low pass filter. Holding the lemon key here will take you to the filter envelope screen, so let's adjust that too. Release the lemon key and change the envelope amount to hear the difference. Now let's add a delay effect. Press the plugin key again and with the left encoder change to the effects section, and with the second encoder choose the delay effect. Change delay time. Let's also add the chorus effect. Press the plugin key once again go to the effects section, and with the second encoder choose the chorus effect. Some more width. Nice, let's sequence that. To use the sequencer, first press the track button and make sure your cursor is in the beginning of the song by pressing the stop button twice. Then press the sequencer button. Then press the left encoder to choose the step sequencer, and now you can just play some notes to find a good sequence. Yeah. Okay, in this sequencer you can change step length with the second encoder, move the cursor with the third encoder and change the length of the sequence with the first encoder. Hold the plus button and play a note to add it to the sequence. Press the minus button to remove all the notes on the step currently selected. It's possible to record more than one note per step, but I won't do that here. Press play to listen to this. Now if you go back to the track screen, you will see your sequence is already there on track 1. Yeah, let's listen to that again and then continue. To add a drum track on the track screen, once again make sure your cursor is in a starting position and then press the plus key. Then press the plugin key, press the plus key once again, and with the second encoder choose the drum sampler and then press the second encoder. Pressing the left encoder, you can now choose a drum kit, and I'm just sticking with the first here. And once you're done with that, go to the step sequencer once again. You can now just listen to your drum sounds. Change the step length to 16 and now you can start recording your drums like the sequence before. Press play to listen to this. Back on the track screen, you can listen to the whole mix. Okay, on to the melodic sampler. To add a sampler track on the track screen, press the plus button once again, then press the plugins button and press plus. Then select the sampler, and now using the left encoder, you can choose other samples by pressing the encoder and choosing one of the file names. I think I'll just stick with the Metallophone here. And now just press play in pattern mode and jam along. Okay, I'll do one more video making more music, but now it's time for first conclusion. So now you know a little bit more about the LMN-3. What do you think of it? Please write it down in the comments below. And to answer the question from the beginning of this video, this is not an OP1 killer. See, I get why people are upset at teenage engineering's price policy, but then again, the OP1 is a very well designed and built piece of hardware that lets you produce a complete song from start to finish. Its synths, effects and sequences are fully realized and easy to use. The LMN-3 has great potential, but at the moment the only people that should really care are developers and maybe Raspberry Pi nerds that have most of the parts needed at home already. The project is still in its pre-release phase and it really shows. I experience frequent crashes and many features you need for everyday use, for example saving songs and loading songs, full MIDI implementation, quantization and so on are missing at the moment. So if you're interested, you might want to check out the emulator on the project's webpage before buying all that expensive hardware to build it. This project is currently searching for developers, so if you're a programmer, please take a look at the GitHub page. And as always, if you're interested in this, please show your support to the developers. This synth has great potential, and despite its current limitations, it's really fun to use. that's it for today. The LMN-3 open source synthesizer, dubbed the OP1 killer by some of you, which it clearly isn't, at least at the moment, but we'll keep an eye on that in the future. It has the potential to become that. And if you found this interesting and useful, please consider subscribing to my channel. This is YouTube, right? And as always, thanks for watching and see you again very, very soon. Bye bye!